Hello everybody. So let's talk about this example that you can see right here. I'll let you read this if you want to. I'll describe it real quick and then I'll tell you how I would solve it. Okay, so we have a rectangle that is going to fit inside this triangle right there. It's described as an isosceles triangle. Okay, and there are lots of ways that you can put this rectangle inside this triangle. Lots of ways that you can do it. You might imagine that, it's a little taller or a little wider than this. There are just unlimited possibilities for how you could draw this rectangle inside this triangle. But there's only one way that gives you the rectangle of greatest size. Okay, so that's what we're after. I want to figure out how should we construct this so that this rectangle is as big as it can get, okay, and still fit in there. So here's how we do it. I have recreated this drawing. Some points that were given as those lines construct that triangle is that this point is 0 and 9, and this point is 9 and 0. Okay? This point's negative 9 and 0. And then the rectangle goes in it like that. All right. Now, in order to find the biggest rectangle that's going to fit in there, and use calculus, we need to put the area or size of this rectangle into some kind of function. Okay? All right, so that's the first task. Now, here's how I would do this. I noticed that in this picture, this point right here where the corner of the rectangle meets this side of the triangle is given in terms of an x and a y coordinate. Now, up there, the y coordinate's left in question, but we'll need to know it, and here's the reason why. For me to express the area of this rectangle, I need to find its area in general. What's the area of a rectangle in general? It's the length times the height, or the length times the width, or the product of the sides, however you want to say it. If I knew the y coordinate of this point where the corner of the rectangle meets this side of the triangle, that y coordinate would be how tall it was. Okay? And the x coordinate is half of its width. Why do I say that? Well, to get to this point, we're saying you go right x and you go up y. So going right x is half of the width. So if I double that, I get the whole width. Okay? So let's talk about how you get the y coordinate. Here I've told you the y coordinate is 9 minus x. Here's how I know that. This side of the triangle is a line, and it has a slope of -1 because you go down 9 and over 9. And it has a y-intercept as 0 for x and 9 for y. So I can get the equation of this line just from that information. It's y equals 9 take away x. So if the x coordinate is just x, the y coordinate would be 9 minus x. So notice I just put 9 minus x right there. Okay? All right, so here's what I get then. That rectangle, which we're trying to determine the maximum size of, has a base of 2x and a height of 9 minus x. Okay? And for me to put these in terms of x just says, well, as you describe this rectangle inside the triangle, the corner is going to hit somewhere along that side, and x just tells me where. Okay? So like if x was 2, this corner would be at 2, at an x coordinate of 2, and so on. So I've got the base and the height of that rectangle in terms of x. Now the area is the product of the base and the height, and so that's 2x times 9 minus x. Okay, so that puts the area as a function of x. I'll multiply through, and I'll say 2x times 9 is 18x, and 2x times negative x is negative 2x squared. Now, so we've got this thing that gives me the area as a function of x, where x is the location of this point. It's the x coordinate of that point. To calculate the largest possible area, I can just solve the equation a prime equals to 0, which finds me a critical point on the area curve. Okay? And additionally, to prove that that is a maximum, I would want to say the second derivative is less than 0. If the second derivative is less than 0, it says the curve's concave down, and the point that I found through the critical point is indeed a maximum. Okay, so that's my objective. Now that I have some function that expresses the area if I take the derivative of that and solve for 0, it will take me to my answer. Okay, so I'll divide that into 3 parts. Part 1, let's find the derivative and solve it for 0. Okay, now as I do these parts, somebody else might do these in slightly different ways, but what you see here is still all the aspects that we have to take care of. So, okay, if the area function is 18x minus 2x squared, then the derivative is 18 minus 4x. Setting that equal to 0 and solving it, I'll get 18 over 4 or 4.5, 4.5. Okay? Now, so that number is key to the solution. It says if that point right there has an x-coordinate of 4.5, 4.5, then this rectangle will be as big as it could possibly be and still be inside the triangle. Okay? Now that might not be the final answer, depending on what about that rectangle they want to know, but it's a big key to the answer, and it may be the answer. We'll talk about it more in a minute. So that's the critical point, all right? Now, to verify that that actually is a maximum, because just because the derivative is 0 doesn't mean what you found is actually a maximum. We sometimes prove that the second derivative is the way that we need it to be to get a maximum or minimum. So I'll show you real quick that it's negative, which means the curve's concave down, and we have indeed found a maximum. So if a prime is 18 minus 4x, the second derivative is just negative 4. And if you evaluate the second derivative at our critical point, well, the second derivative is negative 4 all the time, and it's negative. Okay, this curve is just a parabola that opens down, and so it's concave down throughout the whole curve, including at this critical point. All right, so that number does indeed locate a maximum. Okay, and we wanted the maximum area rectangle. Okay, so how would I interpret this? I got x is 4.5. Okay, so let's go back to this diagram. That means that the width is 2 times 4.5. Okay, see how the width is 2 times whatever the x is? Okay, so if the x is 4.5, 2 times that's 9. Okay, and then how tall is it? Well, the height was this y coordinate, and so that's going to be 9 minus 4.5, or just 4.5. So this is what that rectangle is going to look like. The x coordinate of the corner is 4.5. From that, I can interpret that the base is 9 and the height is 4.5. Okay, and that will be the key to the rest of my answer. All right, so let's see then. What does it ask us about this? So I've answered part A and I've answered part B. It says, okay, what is the largest area rectangle, or what's the largest area that this rectangle can have? Well, so far I've figured out that it's a 9 by 4.5 rectangle. So if I multiply those, I can tell you the area, and that's 40.5. Okay, so 40.5 is what you see here. It did say the instructions to enter a simplified fraction, so I converted 40.5 to a fraction. That's 81 over 2. So that takes care of the first part of part C. Then it says, well, additionally, what are the dimensions of the rectangle having the largest area? Well, that's this part right here. It's 9 by 4.5. Okay, 9 by 9 over 2 if you want to express 4.5 as a fraction, as is apparently the case here. Okay, so that's how we answer it. Notice that I put part 3 as interpret. Whenever I solve the derivative for 0, I'll get some number that will take me to the ultimate answer. But notice that 4.5 itself wasn't the answer. There's lots of things that we can interpret from that. We could say that 4.5 tells me that the largest size that rectangle can have is 40.5 square units. Or we can say that that number tells me that the right, or the dimensions of the largest rectangle are 9 by 9 over 2. Okay, so there will be this step of interpreting based on whatever the critical number is, and how you interpret is all going to depend on what you're asked ultimately to say about the situation, and that's what I see in part C.